Welcome back to the How to Analyze Sports with Excel series. This is going to be part 4. This is going to be by far the most complex part yet. Now what we're dealing with today is stat adjustments. Stat adjustments are what you do to transform raw stats into opponent adjusted stats. You're adjusting your stats based on the strength or weakness of the opponent. Now, like I pointed out in the last video, it's not as necessary to do this in pro sports like the NBA compared to college sports like college basketball, just because the talent gap and the way teams play in the pro sports are not as pronounced. The differences aren't as pronounced in pro sports as they are in college sports, whether it be talent or play styles. As well as in pro sports, every team pretty much plays a very similar schedule, while in college sports, schedules are very different, and a schedule can determine a lot about a team's overall statistics. So while it's not as necessary to do this in pro sports, you still want to do it anyway just to account for the minor nuances, but it's absolutely mandatory to do this in college sports. What I've done in the first 3 videos is that I've programmed a lot of what we've done as we've gone along in real time, but I tried to do that for this video and it just didn't work out because this code is going to be a lot more complex and there's a lot more moving parts. I was filming as I was going and it just wasn't working out because of all the backtracking I was doing and all the adjustments I was having to make on the fly. I figured it would just be easier for me to write all the code first and then go down the code and explain everything what's going on instead of coding in real time, because that just would have been a major pain to edit and it would have been way too confusing with all the backtracking. So I have all the code written out, it's all good to go, it all works, so I'm going to actually explain to you what I've done, and hopefully you can follow along. I'm going to include the link to this workbook as it is in the description of the video, that way you can download it and follow along if you want to. So let's get started. So the first thing I did is I opened the game log file. So what we're going to do is we're going to go game by game and adjust every team's game stats. So here's why we adjust stats. If the Hawks played the Knicks the way they did against the average team on a neutral floor, what would their stats be? So what I've done is I've created 6 new tabs here in a light blue color. So the hold tabs, they're going to hold our information as we're processing it, and the adjusted tabs are going to be the output data for the processed hold data. So let's look at the code. So here's the code. I put it all in the same module. I created a new module just for this. So the first thing I did is I wrote some functions. This first function is called grab league average, and it exists to obtain the league average stats. It's pulling league average stats from the league average tab right here. If you make the token all, it will grab the all line. If you make the token home, it will grab the home line, and if not, it'll grab the away line. We're still using a for loop, but what we're doing is we're using columns.count instead of rows.count because we're looping to the side. We're not looping down, we're looping all the way to the end this way. So columns.count is pretty much the same as rows.count, only you put the row number first and then you put columns.count second. So it's flipped. And you do x1 to left instead of x1 up. So what we're doing is for a equals 2 to g, and then we're creating a variable called output, which is generating a comma separated string of all of these values. So it's going to grab all these values separated by commas and return the average output as a string of separated values by comma. And then the same thing for grab team raw. It's grabbing the team's season long raw averages from these tabs. It's doing the same thing. It's looping through, making comma separated values all the way down, and it'll return a string of comma separated values. And I'll show you what that looks like, just so you have an idea. All right, see how these averages right here? See how the string is nothing but comma separated values? Those are all our values from the league average tab separated by commas. That's what it's doing. However, in grab team raw, we still have to find the team's row first, and then we can move on and do the output. So that's what that function does. So these are 2 simple functions to help us grab the stats that we need easier within the adjustment macro. All right, so here's the main macro we're going to use. It's called first wave adjustment. It's our first wave of stat adjustments. It takes the raw stats and adjusts them into a first wave of adjusted stats. So the first thing we need to do, of course, is define our start and end variables, but then we clear our hold sheets, which are sheets 9, 10, and 11 right here. So when it's appending data, it's not adding to data that already exists. This right here is important. So we need to define all these variables as doubles. A double is basically a number with decimals. An integer is a number without decimals, but if you want decimals, which all of our values are, you're going to want to use double. We have to define them because we're going to use the split function, and the split function is what splits our comma separated string into individual tokens. But Excel is going to treat all those split tokens as strings, and if you don't define them, then it's not going to be able to calculate because it thinks it's a string and not actually numbers. So we need to define them as numbers so Excel knows that they're calculable numbers. So this is no different than what we've done already. We're just obtaining data from the game log. We've already done this. I simply copy and pasted this from the game log parser that we wrote already. All right, so what we need to do is we need to obtain all the league average stats for home, away, and total from our grab league average function. So we're grabbing league average all stats, league average away stats, and league average home stats. And then we need to obtain the opponent's season averages using our grab team raw function. So if the team that we're adjusting for played an away game, then we need to grab the opponent's home stats and vice versa. So now we're going to use the split function. So the split function takes our comma separated string, as you can see with the tooltip right there. It takes that comma separated string and splits them into individual tokens. So the syntax is split, and then you have your variable, which is league average string. We're splitting that one. And then you do a comma, and then you put what the delimiter is. The delimiter is the character you're using to separate. In this case, we're using a comma, so that's what our delimiter is. And this number right here is the ordered number that you want to pull from. So if there's 8 comma separated values in the string and there's an 8 right there, it would pull the 8th value from the string. However, this is different. It starts at 0. So whatever number you want to pull, you need to subtract 1 from. Here we're using 24 for tempo because it's the 25th column. See, tempo's right here in column 25Y, but we need to subtract 1 because, like I said, it starts from 0. You need to subtract 1. So pretty much these numbers right here are just the column numbers minus 1. So just think of the split function as dividing up your tokens into separate values, and then you just call on the order number you need. Okay, from there we need to calculate our advanced game stats. Nothing new, only we're doing this in macro form this time. So team possessions. So all these are game stats, by the way. They're all the stats that were in the individual game that we're adjusting for. So team possessions is how many possessions the team had in the game, team offensive efficiency, opponent's possessions, team defensive efficiency, team effective field goal percentage, team defensive effective field goal percentage, team offensive rebound percentage, defensive total, free throw rates, and then our opponent's stats, opponent free throw rate, opponent turnover percentage, opponent rebounds. These are all our advanced stats right here that we're calculating. Moving down, we need to split the opponent's season-long raw average string into individual tokens. The split function again. The column values are a little bit different here. We're using the ones from the season. So we're using these columns right here. So offensive efficiency, column 27, right here, which is really 28, but again, minus 1, don't forget that. And we're just splitting that up and grabbing our individual values. And like I said, the split will automatically return a value as a string, so that's why we had to define them as doubles earlier to make sure Excel knows that they're numbers. Otherwise, you'll get an error when you try to use them in calculations because it doesn't know that they're numbers. All right, now the important part, the stat adjustments. This is where all the magic is going to happen. So all of our stats except tempo are going to be adjusted the same way. To adjust stats, you take the game stat. So in this example right here, we're going to use this line as our example. You take the game stat, so the team's offensive efficiency for the game, minus the opponent's average opposite stat. In this case, the opposite stat is defensive efficiency. So minus the opponent's season average defensive efficiency minus the league average efficiency. So I'm going to write out an example right here. Say the game efficiency was 100 and the opponent's average for the season was 105 and the league average for the season was 95, right? So that would be 100 minus 105 minus 95, which equals 100 minus 10, which equals 90. The stat was adjusted downward because the opponent's average defensive efficiency for the year was 10 points per game higher than the league average, so that means their defense sucks. So you adjust the game efficiency downwards, taking that into consideration. So if the team were to play exactly like they did against the league average team, they would hypothetically only have an offensive efficiency of 90 in that game against the league average defense. And you do that for all the stats. The only minor difference is that for offensive rebounds and total rebounds, you use a plus instead of a minus. But apart from that, every other stat is adjusted the same way. Game stat minus opponent's season-long average opposite stat minus league average stat. Tempo is done completely different, and this is going to get confusing. I've been doing adjusted tempo for years and it still confuses me. So I did an example here on the sheet to explain exactly what we're going to do for adjusted tempo. It's the adjusted tempo waterfall example because it's a waterfall of steps that you have to follow to get to the end game of adjusted tempo that I'm going to put here in yellow. I use a college basketball example here because I feel like it'll help illustrate the concept better than NBA because of the massive gap in tempos that you find in college, not so much in the NBA. So Virginia and North Carolina played a game in February this past year. I use this as an example because Virginia has the slowest pace in the nation this past season and North Carolina had one of the fastest. So it was truly a matchup of two opposing styles. So Virginia's season-long pace average was 59.4 possessions per game. North Carolina's was 74.3. The national season average was 67.8. So these two teams were on the extreme. So the first thing we need to calculate is expectation. I've done a video on expectation before, but I'm going to rehash the points here. Expectation is what could reasonably be expected based on the stats. So the expected pace of the game was the national pace, which is B7, plus Virginia's differential, which is B5 minus B7, plus North Carolina's tempo differential, which is B6 minus B7. So we could expect the pace of the game to be 65.9 possessions, but the actual pace of the game was 59.4, which is right in line with Virginia's season pace, meaning the game was played to Virginia's style. So the difference here is E6 minus E5. It was 6.5 possessions slower than average. So in other words, Virginia played the way they wanted to play. So now we need to sum up the season-long pace of both teams equals B5 plus B6, which is 133.7. Virginia's percentage of that sum is B5, their season-long tempo divided by H5, 44%, and then North Carolina, B6 divided by H5. So now we need to calculate a share of the possession differential between expected and actual. All you do is E7 times Virginia's sum percentage, H6, and then E7 times North Carolina's, H7, and this is each team's share. And then you add this number to their season-long tempo equals K6 plus B5 equals K7 plus B6, okay? And watch what happens when you do an expectation calculation with this. Equals B7 plus N6 minus B7 plus N7 minus B7. 59.4. Oh, what do you know? It's the actual pace of the game. We adjusted the tempo to predict the actual pace of the game. This right here, the adjusted tempo represents how each team wanted to play. Virginia wanted to play at a slow pace, slower than their season average. So did North Carolina. That's what adjusted tempo is calculating. It's not so much adjusting for opponents' weaknesses or strengths, but it's adjusting based on tendencies. That's what we're trying to measure here. I know that's very complicated, but that's how you adjust tempo. Here's how we did the tempo adjustment in the macro. We first grabbed the team averages and opponent's average tempo from the grab team raw function, which is column number 25, minus 1 equals 24, and the comma separated values. We do the expected tempo for the game, which is league average tempo plus team average tempo minus league average, and then plus opponent's average minus league average. And then the actual tempo for the game, team possessions plus opponent's possessions divided by 2. The possession differential sum, which is actual tempo minus expected tempo. The percentages, team average tempo for the season divided by the sums and opponents. And then we adjust our tempo, the team average tempo for the season plus possession differential times percentage. If you have the waterfall right here, which I will include in the document, you can follow along and it'll come to you. So now that we have all these stats adjusted, we need to append them to the holding sheets. The holding sheets are going to hold our data. Pretty simple stuff here. If the location was an away game, we're going to append it to the away sheet. Same concept we did earlier. We're just reading what the cells contain and appending the values on there. Not much new here. Row is another function that I added, which is find team hold away. So it's pretty much the same functions we had earlier, only it's finding the team's location in the holding sheets. Nothing different, just a different name of the function, that's all. So sheet 9 is the away hold, sheet 10 is the home hold, and sheet 11 is the season hold. Nothing but appended values here. Now that you've been able to absorb that and see everything we've added, I'm going to run the function. First wave adjustment, and here we go. And it'll start calculating. When it's done, I'll get back. Okay, everything's been calculated, so we have our held values. So pretty much what we're going to do here is the same thing we did in the earlier videos in the series and aggregate all this. But we're not going to do it through Excel because we don't want these adjusted tabs to be full of functions because we're going to want to reference them later. And we don't want to reference Excel functions. We want these values to be static, so that's why we're going to use macros here. So we have this macro called subHoldAggregate, and this is going to aggregate all the data in the hold sheets. So first we want to, of course, clear the sheets of the adjusted sheets to make sure there's no data there. And then we're going to run 2 for loops. So this is an example of what we call a nested for loop. It's a for loop within a for loop. It's the first time we've done this, and it is what it is. It loops a for loop within a for loop. It's Inception almost. So what we're looping through here is, of course, we're looping team by team, but then we're also looping to the side here. We loop down, but within that loop down, we're looping to the right. And we're calculating all these values one by one divided by games. You can see it here. Games equals sheet 2 cells.value. We do that before the nested loop. And then we start at 3, column 3, and we go all the way to column 14 right here. And value is sheets 9.cells, A, which is the row we're on, and B, which is the column we're on, to get the value, and then we divide that by games, and then we add that to the corresponding sheet. So sheet 12 is the away sheet, sheet 13 is the home sheet, and sheet 14 is the season sheet. And we append that to these 3 sheets right here. It's pretty simple. These are nested for loops. They're very functional. They're very useful. So there's really not much to it. I'm going to go ahead and run this as well. Hold aggregate. And there we go. That's simple. Now we have all our adjusted stats calculated. This is our first wave of adjusted stats. Congratulations. So look, you average everything. The average tempo is still 101.62, which matches the league average. So our adjusted stats still, when aggregated, are still all reflected by the league averages. They're just adjusted based on opponent. So here we go. The Hawks' adjusted offensive efficiency is 107. Their raw offensive efficiency was 106. So their overall adjusted offensive efficiency got adjusted upward because they played a stronger schedule than other teams, I'm assuming. That's why their number went up. Either that, or they played better against better opponents, and therefore their adjusted numbers went up. Because adjusted numbers can go up for 2 reasons. You either played really good against good opponents, or you played a stronger schedule, or you played less bad against bad opponents. There's a lot of different factors here as why your number could go up or down. But in college, for example, the teams that play weaker schedules are almost always going to have adjusted numbers lower than their raw numbers. So there we go. We have all our adjusted stats. Now we can do this again, only instead of adjusting on raw stats this time, we're going to adjust on the adjusted stats. So we're going to adjust the adjusted stats. It's called a recompile. You keep recompiling your stats until they stabilize. You can do this as many times as you want. You can do it once, twice, 3. You don't have to do it at all. But the more you do it, the more your numbers will stabilize. So our function here is called sub second wave adjustment. It's the second wave of stat adjustments into a new adjusted stat. Now, not much has changed. I pretty much just copy and pasted the first wave adjustment macro and changed only a few things. I didn't change anything up here. We're still going to use the same hold cell sheets. The only thing I changed is I created a new function called grab team adjust, which instead of it grabbing from the raw season tabs down here, it's grabbing from the adjusted tabs because we're adjusting on our new adjusted stats. So here's the function right here. There's really not much different. Instead of pulling from these tabs, it's pulling from these tabs. That's all the change I made. Nothing different. And then the only other change is since the grab team adjust return value is a bit different because it has less columns, these numbers are different. That's it. It starts at column 3 and goes all the way down to 13. See, column 4 minus 1 equals 3 all the way over. And then, of course, the tempo right here, column 2. Those are the only changes I made on that macro. That's it. And then we can run it again. I mean, there's really not much to it. There's only 2 changes. And now we can do the second wave adjustment right here. There we go. Here's our second wave adjustments. And now all we need to do is aggregate. And we can use the same hold aggregate function because it uses the same inputs. So we don't need to make a second one for the second wave. We can just use this one over again because it's reading off the hold sheets in which nothing changed. So here we go. And here's our second wave of adjusted stats. And we can keep doing this over and over if we want to. In the NBA, it's probably not that necessary because, like I said, the talent gap and everything is not that big and the schedules are pretty much all the same. So that's probably all we really need right here. But in college, you're going to want to do it multiple times because the first adjustment in college is just your starting point. And then you want to adjust off your starting point into the second point, and then the second point on the third point. In college, you're going to want to do it at least 3 times, if not more. So for our second wave of adjustment, the Hawks' offensive efficiency went to 105.48 compared to their raw average of 106.84, so it went down this time. So the second wave actually caused the Hawks' efficiency to go down. So if you wanted that number to stabilize, you would keep doing this over and over again until it stabilized. So you probably might want to do it again, but it's up to you. The difference probably isn't that great. It's diminishing returns here, but that's up to you. This is your model. You can do what you want. So that's pretty much how you adjust stats in Excel. I know it was complicated. That was probably a lot to absorb, but once you can get that down is when you can really unlock the key to true advanced sports analysis and really start to get some valuable insights. The next video is probably what you've all been waiting for. We're going to take all this data right here and turn it into stuff we can actually make sports bets with. So stay tuned. Until next time, this is Sports Betting Truth signing off.